Today we're interested in looking at what happens to graphs as they approach asymptote. And as you guys should know, there are only two things that a graph can do as it approaches an asymptote.
Increase or
Go up or go down. That's all it can do. Very good. So that means as we're approaching an asymptote, what are our possibilities for a limit? Positive infinity or negative infinity. So that's what we're determining. Now technically there is not a limit. Why is there technically not a limit?
Because both sides are meeting out.
Because infinity is not an actual y value, and limits are actual y values. So technically, the limit does not exist. But we're going to say it's going to infinity or negative infinity to talk about what the graph is doing as we approach an asymptote. So that's the purpose of what we're doing today. So the first thing we want to do is remember how to find asymptotes. If I'm giving you a function, how can I determine if a function has an asymptote?
The denominator.
What about the denominator?
What makes it 0?
What makes it 0? What else has to happen? Because if the denominator is 0, that means I'm either dealing with a whole or an asymptote. How do I tell the difference?
One cancels with the other.
Okay, so which one's which?
Whole cancels.
A whole cancels out. An asymptote does not. So an asymptote happens whenever I plug in and I get a number over 0. Number over 0 means I'm dealing with an asymptote, and then my graph is either going to go to infinity or negative infinity. That's what's going on there. So the first couple problems we want to do, we want to practice on finding asymptotes. So if you look at number 13, we can do this one just verbally. We don't need to write it down on 13. So I have f of x equals 1 over x squared. It says find the vertical asymptotes, if any, of the graph of the function. So where are my asymptotes on 13, if any? 0. Okay, how do I know 0 is my asymptote?
Plug in 0.
Plug in 0 makes the denominator 0. The top is still a number. Number over 0 gives me an asymptote. All right, let's look at 15. F of x equals x squared over x squared minus 4. 2 and negative 2. 2 and negative 2. I've got asymptotes of 2 and negative 2. Everybody agree with that?
14.
What can I on 15?
Okay, yeah, that's okay.
What can I do? What can I do on 15 to find the 2 and negative 2? What do I do to x squared minus 4?
Factor.
Factor. Good. What about 17?
There's none.
There is none. Why?
Because no matter what
when you factor that out.
Can't factor that.
whatever you plug in.
Whatever I plug in,
to plus 1.
it's always going to be positive. So I can never get a 0. So 17 does not have an asymptote. And what about 19? X minus 2, x plus 1. So what does that give me?
2 and negative
2 and negative 1. What do I do to make sure they're asymptotes and not wholes?
1.
Plug in 2 and negative 1 to the numerator. So what happens when I plug in 2?
4 minus 2.
It gives me 4 minus 2, which is 0. So 2 is fine. What happens when I plug in negative 1? It gives me another number. So both of those would be asymptotes. What about 29?
No. Wait, no. Oh,
What does a graph of tangent look like?
it has the asymptotes.
It's got asymptotes. Where are they at?
Pi. At every interval. No. Do I use that?
Yeah, you can use that.
At 1? No. Undefined. No.
Every pi over 2.
Go.
And then asymptote at every pi over 2. Why? Because it's undefined. And wherever you're undefined, that's where tangents and asymptotes are at. Good. Except actually, in that particular problem, it's tangent of pi x. So what x values? Every 1/2 value would give you that. What about 31?
0.
0. But can I use 0? Is 0 an asymptote?
No.
0 is not an asymptote. 0 is a whole. But what else? What else makes sign 0? Pi.
Oh, yeah.
So pi, 2 pi, 3 pi. So every pi starting at pi would work. All right. Now let's look at some of the limits. So let's look at 37. So on 37, I have the limit as x approaches -1 from the right. And it is 1 over x plus 1. So it's asking me to find a limit. It doesn't matter if I'm going from the right, if I'm going from the left, or whatever it is I'm finding. What do I always want to do when I'm finding a limit? Plug in. What happens when I plug in -1? I get 1 over 0, which means I'm dealing with an asymptote, which means my limit has to be either infinity or negative infinity. So I need to figure that out. Here's how we're going to figure that out. Notice that this is -1 from the right. So I want to I'm not going to pick out a number, I just want to think about a number to the right of -1. If I plug in a number to the right of -1, does that make my denominator negative or positive? It makes it positive. And the top is also positive. So since I'm positive, which infinity am I going to go to? I'm going to go to positive infinity. So let's look at the graph of that and verify that's what we found. So we had a fraction, it was 1 over x plus 1. And as we approach -1 from the right side, where is it we're going? We're going to positive infinity, just like we said, correct? Let's look at 41. Which side are we going from on this one?
Right.
From the right? 1 from the right? Alright, so we want the limit as x approaches 1 from the right of x squared over x minus 1 squared. Okay, and again, Garrett, what do we always do when we find the limit?
Plug it in.
Plug it in. What happens when I plug in 1?
You don't want to plug in one. You want to plug in a number to the right of one, right?
Not yet. What
When
do
you
we?
plug in 1, you get 0.
I get 0 on the bottom and I get a
One.
number on the top,
That means it has to be.
which means I have an asymptote. So now I'm considering infinity or negative infinity. So I think about a number just to the right of 1, just to the right of 1 in the bottom.
Gives you
Gives me what?
Positive.
Positive. Just to the right of 1 in the top,
positive.
also a positive. So that means this is going to positive infinity. So let's verify again. So as you notice, hold on, I'll put what did I put in? It should be x minus 1.
Plus.
Oops. Laugh at me. All right, so as we see, as we approach 1 from the right, where's my graph going?
Up.
Positive infinity, like we said it would. Let's look at 45. Limit as x approaches 1. x minus 1 Alright. Number one rule in finding limit.
Plug in.
What happens when I plug in?
You get 0 on top,
You get 0 on the bottom.
1 0 on the bottom.
So what am I dealing with at 1?
Hole
I'm dealing with a hole.
cancels.
So that means what type of limit am I going to have?
And
Number.
I'm going to have a number instead of an infinity. What do I need to do to help me get to that number?
Cancel out.
Cancel out. So the limit as x approaches 1 of 1 over x squared plus 1, that means my limit is 1/2. Okay, so they'll throw those in there just to keep you honest and make sure you're doing what right at the very beginning.
plug
Plug
in.
in.
Plugging in. They want to make sure the first thing you do is plug in. So make sure you do that.
So when you have a hole here, you have to do with the number.
You're going to a number if there's a hole.
And if it's asymptote,
If it's an asymptote,
it's negative infinity.
it's negative infinity or positive infinity. That's correct.
Got it.
All right, two more. I'm going to look at 47. The limit as x approaches 0 from the left of 1 plus 1 over x. So what happens when I plug in?
0 in the denominator.
I get 0 in the denominator, number on the top, which means I have
Asymptote.
an asymptote. So that means my options are infinity or negative infinity. Okay, this is 0 from the left, so what do I want to think about?
The number to
A
the
number
left.
from the left.
The number just to the left of 0, if I plug in a number just to the left of 0. It's going to be a negative on the bottom, which makes that fraction negative. And all I care about is that fraction, which means this is going to negative infinity. So as we approach 0, we're going to negative infinity.
So all you care about is the fraction.
Right. So let's look at that one. Um, 1 plus 1 over x. And we were approaching 0 from the left, and I'm going to negative infinity. All right, 49. Limit as x approaches 0 from the right of 2 over sine of x. What happens when I plug in 0?
You get 0.
2 over 0, which means I'm dealing with asymptote.
Asymptote.
So, think of a number just to the right of 0.
1.
1. Where's that going to put me? What quadrant does that put me in?
First.
First quadrant, and sign in the first quadrant is
Positive.
positive. So positive on the bottom with 2 means this is going to
Infinity.
positive infinity. So let's check that. And we're approaching 0 from the right. 0 from the right, am I going to positive infinity? Yes. What does this graph look like? Cosecant. Why does it look like cosecant?
Because sine's in the denominator.
Sine's in the denominator, which is the same thing as having what in the numerator?
Cosecant.
Cosecant. So this is really just the graph of cosecant. So there's my asymptote. I'm positive on the right, which means I'm going to positive infinity.